Yo, what's good? Stu here, Stu TV. I cover all things blockchain, metaverse, crypto, NFTs, all money making opportunities in the space. Just wanted to make another beginner series video, and specifically with this video, just gonna be covering some layer 2 blockchain solutions. So I know we got into different beginner topics going through these different videos, but now I just want to get into some more scaling solutions in this particular video, show you some effects, what that exactly looks like on the blockchain, and how scalability and what it looks like in these current modes of new just forms of accepting payment, getting transactions through. So it's a lot that comes into play, and you talk about mass adoption and getting people to understand the totality of this space and where the direction of it's headed. But let's get into it. So we're gonna read some of this article, and then I'm gonna pull some examples of this show. So what are some layer 2 blockchain solutions? So let's scroll down a little bit. Scalability is defining issue for future cryptocurrencies. Many early blockchains like Ethereum and Bitcoin networks were not designed to handle the volume of traffic they now support. Layer 2 blockchains are blockchains built on top of the underlying networks that enable faster, cheaper transactions. This opens the door for newer blockchain applications and increase efficiency as a system as a whole. Bigger, faster, better. Are we talking about the latest blockbuster? No, we're talking about humble old blockchain and its quest to keep up with the ever increasing amount of activity on its network. Today, let's take a look at layer 2 blockchains and how they're enabling existing blockchains to scale. So they have blockchain has driven an incredible rap for innovation, all just because of one premise: the ability to move value around autonomously. Despite its evident utility, blockchain is still facing real world limitations. Unfortunately, that's down to one big problem: it's not designed to scale. Transactions on older networks such as Ethereum or Bitcoin are notoriously slow and expensive for users, problems that accelerate as more people use those networks. This makes them impossible to use on a mainstream basis. So how can the utility of a blockchain be brought to the bear on a larger scale? So just even with that particular aspect, yeah, just a lot of different blockchains that were created now they're trying to find different scaling solutions. This is the point in time that we are in the market, so that's why it's still early. Is this now the foundation of the technology has been laid down? Now it's time to build innovative layers on top of that, so there's still opportunities within that realm. So it just shows the dynamics of how early you could really be in the space. Well, let's keep reading. What is a layer 2 blockchain? A layer 2 blockchain is a network that aims to scale its parent network by handling part of the blockchain's capabilities with a secondary chain. There are 2 different scaling solutions, and each of them have their advantages and disadvantages. But what is the point of a layer 2 blockchain anyway? So let's kind of skip through this. The most 2 obvious examples of a layer 1 network are Bitcoin and Ethereum. These are base networks that handle every aspect of every blockchain transaction on chain without any assistance from any other network. But this means transactions on those blockchains are extremely heavy and slow. Every single new blockchain must be validated by the network. Then before a new block is added to the chain, it must be checked against the entire history of the network. There's no shortcuts in layer 1 blockchains. So it has like scalability and how these different networks tie in with the transactions, how they get used, how do they handle congestion. So a lot of these different solutions, although lay the foundational layer for where we're at in this particular crypto market, now building on these type of solutions and making it more efficient, faster, scalable, speed, transactions. Those are going to be the most important things moving forward. How these different layer 2 solutions and what they support: micropayments, accessibility. A lot of those are very key terms of fundamentals as you just begin reading. But scalability is the ability of a system to handle increased load of traffic. In the context of blockchains, its ability to process more transactions per second in order to meet the growing needs and demands of users. A good analogy would be to imagine adding bricks to a pile. Only instead of adding each new brick to the top of the pile, you're adding it to the bottom. To add a new brick, you had to pick up all the existing bricks. Plus, that pile is constantly growing and becoming heavier. There's more demand than ever for new bricks to be added. So each new add becomes heavier and slower. On the other hand, the sheer computer power retained to complete the process is what keeps the network in your crypto secure. But on the other hand, it renders the system totally impractical for everyday use. Essentially, that's how blockchains work and how they can become becomes slow and congested. So just being able to have a brick in a different layer to where if you want to transact and they have 24 bricks before and you're number 25, you not also have to transact your brick, but you have to pick up all those other 24 bricks on top of your 25th transaction. So that could be wear and tear within the network. That could cause congestion. That could cause speed. A lot of people are not going to be wanting to interact with that technology on an everyday use because it's not convenient for the everyday user. That is the point of blockchain as far as these layer 2 solutions scaling that. So why does it matter? To give you some idea how limited the system could be, let's quickly look at Bitcoin. The Bitcoin can process a maximum of 7 transactions per second, which may seem pretty fast, but by comparison, the Visa network can process a normal 24,000 transactions per second. This is why the ability to function as a global payment system, looking at these two networks side by side, it's clear that Bitcoin and layer 1 blockchains like Ethereum and Binance is simply not capable of being used universally. It doesn't have that capacity. This is where layer 2 solutions are pushing things forward. Layer 2 blockchains are so called because they sit as a second layer on top of the base mainnet. Layer 2 has one purpose: to allow the network to process more transactions per second. Accordingly, they move transactions off of the heavy mainnet. Different layer 2 solutions achieve this slightly in different ways, but the objective is always the same: streamlining the amount of information that needs to be validated by the cumbersome underlying blockchain. There are two multitudes of blockchain solutions, and each of them have their advantages and disadvantages. So let's actually look into the type of blockchain. So now you've got a big picture where we're at. So a lot of these different technologies where Bitcoin was created back then in 2008, technology or how they identified and how they wanted to scale up this particular solution. But as you get more users into the network, as you get more people that's transacting different money, then the technology has to mature to a place, and there's going to have to be new solutions going forward to build on top of the tech. So layer 2s are just built on top technology, on top of the base mainnet that already exists today, and adding on to that those particular technologies. And you could talk about layer 3 solutions and possibly just different other things, but right now we're going to talk about L2 scale blockchain solutions. So let's get into some types. Side chains are independent blockchains that have their own consensus mechanism and connect to their parent chains via two-way bridge. This blockchain bridge allows the transfer assets between the two. In the short, the layer 2 network can execute transactions cheaper and faster, but they also have a connection to the parent chain. This allows users to bridge their assets back and forth and benefit from the transaction speed separate chain can offer. While that simplification, make sure you check out an article what sidechain is to find out the details. So let's actually click on the article and see if we can just read exactly. Let's read into this particular article. Sidechains are independent blockchains that connect to their parent chains via two-way bridge. So sidechains, use cases, why we need them, directly contribute to improving the efficiency of the mainnet. Here's why sidechains are critical to the entire ecosystem. Scalability. Sidechains are built to tackle the issue of blockchain scalability. Sidechains operate separately from the main blockchain so they can process blockchain transactions more quickly and efficiently. This in turn makes the parent blockchain faster and cheaper to use. Flexibility. Sidechains offer more flexibility to developers than the main blockchain. Developers can experiment with new applications and features on the sidechain without reaching the security and scalability of the mainnet. Further, these tests significantly cheaper because sidechains have lower congestion. Upgradability. Sidechains are highly upgradable. Developers can easily modify and upgrade features, functionality of a sidechain without affecting the main blockchain. Besides, developers can also test networks on upgrades and sidechains to avoid introducing bugs within the main chain. You have functionality. So you have scalability, functionality, upgradability, being able to have flexibility. So just breaking all that down with sidechains, the whole point of sidechains is just offer another option or an extension of that particular blockchain or ecosystem, more like a branch of a bank. You have Wells Fargo as a main bank, and then you have all these different extensions just off that main bank, but it still goes through transactions and that money still circulates throughout that entire banking ecosystem. And that's how the scalability and flexibility with all these different blockchains and side chains specifically, to where you could have, you're still interacting with that particular network, but you're operating it in a more efficient and a more lower cost at opportunities, but still benefiting for the main technology and mainnet of that ecosystem. But let's look into how do sidechains work. Blockchain bridges, facilitating the connection to the sidechain. But essentially, when you send funds to a sidechain via bridge, assets do not really move from the sidechain and the parent chain, or vice versa. It's basically an imaginary transfer. Instead, you transfer assets to the output address that will stay locked up on the main blockchain after a brief waiting period for security. You receive your new assets to represent them on the sidechain. When they're done using the sidechain, you can transfer the assets back to the bridge again. Doing this controls the equivalent amount of cryptocurrency on the sidechain and unlocks the cryptocurrency on the main chain. Thus, assets on sidechain are merely pegged to those on the parent chain. So just having two-way pegs, and all right, this particular asset and this cryptocurrency, price-wise, is the same that validates this cryptocurrency and this USD dollar price-wise based on the amount of tier of market cap and price, to where you have that two-way peg to where you could transfer from either way or other. And then you have smart contracts. So smart contracts, since there is no real way to transfer assets between side chains and the main chain, something must facilitate the connection between the two-way peg. So basically, with a smart contract is an automatic sequence of instructions that is generated or triggered anytime this transaction is recognized, or anytime it receives that in a particular contract or code, that how it's coded up to match that specific language in the smart contract. Being able to have that with a side chain and then also paired off with that main chain is what's going to make that peg to peg transfer. But let's go on side chains versus layer 2 blockchains. What's the difference? Side chains and layer 2 blockchains both address the same problem, blockchain scaling, but layer 2 blockchains are built on top of layer 1 blockchains. In comparison, side chains are separate, independent blockchains with their own consensus mechanisms and their own native tokens. This basically means that layer 2 blockchains rely on the main chain's security, but side chains have their own security mechanism. Side chains could be used as a testing ground for developers. They can use side chains and enable functionalities that are not available on the main chain. So we can actually just look examples of sidechain implementation and blockchain projects. Polygon was launched in 2017 as an Ethereum sidechain known as the Matic network, with Matic as its native token. However, rebranding as Polygon includes some layer 2 characteristics. These designers developed it as a solution to Ethereum's high gas fees and scalability issues. Further, can seamless transfer Ethereum dApps to the Polygon network because they both use Ethereum virtual machine. Polygon has gained popularity over years, ranking in well-known partnerships. For instance, Starbucks is using Polygon for its loyalty program. But yeah, guys, just to sum that up, it's a lot to this. It's breaking down, and that's just one, and we're definitely going to get through all the others. But don't overwhelm yourself learning all this particular information. It could be a lot of time, so just make sure you can always feel free to rewind the video and watch back. But let's go on to our next one. Roll-ups. Blockchain rollups are another type of layer 2 solution that involves pushing multiple crypto transactions together in one block. That means they are processed in a single transaction, which reduces fees for the user, but also saves time on the blockchain, which can otherwise cause network congestions. These are two main types, Optimisim and Zksync. Both rollup types consolidate transactions, but methods are more decentralized than others. Optimism is a great example of a chain that uses optimistic rollup to scale Ethereum. So you just have that particular one. Why are layer 2 blockchains so important? Lower costs and more efficient for users. For users, these blockchains are dramatically faster and cheaper to use. Keeping the nuts and bolts of a low value transaction off chain means users can transfer assets quickly with minimal costs, and you have broader blockchain utility. And then just a lot of these is breaking this down. So getting into our next article, just want to read this. What are layer 2 crypto protocols? Top layer 2 crypto projects to watch. What are layer 2? Layer 2s are off-chain vertical scaling solutions that run on top of layer 1s like Ethereum. Types of layer 2s include optimistic, zero-knowledge rollups, state channels, side chains, and nested blockchains. So it just shows layer 1s are accountable for security, data availability, and decentralization, as layer 2s handle transactions and scaling. Layer 2 crypto projects have been gaining transaction and the usage because of Ethereum high gas fees and slow transaction speeds. Layer 1 blockchains, first generation blockchains such as Bitcoin and Ethereum, have experienced blockchain trilemma, scalability, decentralization, and security. So just being able to cover all this. So let's actually scroll down a little bit. So let's actually scroll down in this particular article. We're going to look at the different types of layer 2 solutions in crypto and how do they work. The application and use of blockchain technology are growing, and layer 2 protocols must rise to the occasion to improve on their layer 1 counterparts. Understanding the common L2 chains can provide more insights into how they could be major milestones in blockchain evolution. Here's some common L2 protocols. Nested blockchain. Design of a nested blockchain compromises a primary chain and some secondary chains that ensures the network can seamlessly function jointly with other networks. The primary chain is accountable for assigning tasks, regulating the work parameters, resolving disputes when necessary. The secondary chain executes the transactions of the primary chain and send feedback to approval to the main chains. So just to sum that up, just to give you more of a layman's terms definition, let's say that you have an office or a different room, and then from that particular office you have all these subset branch offices from that particular room or just off rooms, and then all these particular rooms outside this main room is responsible for handling all the day-to-day tasks, all the different minor details, everything that goes on with that particular transaction or how just information is reported back. But at the end of the day, all these different branches of rooms are enabled to report back to the main office or to the main chain without bothering about all these particular details and checking every little thing in every transaction. So that's more so of a nested chain. You could think of this like OMG Network. So there's different type of ways on how they want to be able to get different transactions approvals to the main chain. But I'm going to show you some different examples. Side chains, as the term implies, a side chain is a side network linked to a primary blockchain through a two-way peg. You can think of as forests where trees act as side chains while the main forest is the main chain. The main goal of side chains is to handle the high number of transactions. As such, they support layer 1 blockchains by verifying transactions freely from the main chain. However, you must trust that side chains operate appropriately as they control assets on the main chain. So we just went over that before. Let's go over the state channels. State channels enable party to interact directly on the blockchain, providing an option of executing transactions without considering the main chains. Moreover, the validators can take less time verifying transactions, improving process of speeds of layer 1 chains. State channels don't rely on transaction validation on layer 1 networks, but instead use smart contracts to perform the same roles. When a transaction is finished successfully, the channels ensure secure and storage on the main chain. So one thing I could definitely think of, I had covered before, but fractal Bitcoin, having these smart contracts coded in to match that of that particular main chain, with also being able to have the functionality and access of things like Marco payments, the Lightning Network when it comes to like Bitcoin. So these different state channels are how they interact with these particular assets and how state channels are going to be involved. That's another option that you can get into. Rollups. Rollups are layer 2 that facilitate computations outside the main blockchain. The transfer transaction details place a certain interval, hence offering the necessary backup for maintaining records. Besides, rollups manage transactions with minimal interface to the main chain. Therefore, they can ensure transactions are processed faster at minimal cost. Optimistic and zero knowledge are common types. These layer 2 protocols intend to expand thoroughly of layer 1. They minimize computation on layer 1 by processing transactions off-chain, significantly improving and processing speeds. Besides, they obtain their security from layer 1s by rolling transaction outcomes. So just breaking that down, in particular, optimistic rollup. So let's take all the instances as far as these different transactions are all validated on this particular network, but it just also has a holding period to where, let's say a transaction didn't go through, or you want to dispute a transaction, period to which you can go in and dispute that transaction and validate it, and that smart contract will compute whatever that you're looking for in terms of that transaction, that total amount in USD, or whatever you're looking for that made you want to dispute it in the first place. You have the option, but just on the optimistic roll up, all these transactions are just being able to be transacted on the network as far as being validated by those Vista validators off top. So it's like actually going to a place where nobody really has to get checked when they come in. Like if you're rolling into a specific venue or a club or a bar, nobody really has to get checked out. But let's say something happens, then you might have to get spot checked at any point. So it could be things where you're validated coming in, but you could also, if there's fraud determining or there's something up with the network, then you could be able to go back and retrace and fix that correction as far as optimistic rollups. But the point of that is having different validations through the network is allowing for those processing speeds to where it could be significantly faster. You don't have to verify each individual one because you're looking at scalability and speed. And then also, if there is a congestion or flaw within the network, how can you also automate that process in an effective way as well? How that speed and transaction gets in sync back in that particular network. So it's just a lot to it when it comes to optimistic rollups. And then you have zero knowledge rollups, are similar to optimistic rollups that are combining L2 transactions performed off chain and publish them as a batch of L1s. But instead of assuming transactions are genuine until confirmed otherwise, ZK will allow validity proof to verify whether transactions are authentic or not. So that's a difference between zero knowledge and optimistic rollups. So zero knowledge rollups is essentially just taking like a whole list of transactions combined like a bank statement and wrapping all those transactions up in one without no knowledge and just validating it on the network. Now it does allow for like different things, so it's more like a cartography without being able to verify, but it also has different underlying processes on other aspects of verification that make it transacted and secure, but also like different things like that you can see could be good for like healthcare, photography, or just different industries, how that particularly looks like maybe an NFT project specifically. So like zero knowledge, like Zksync is one that we'll just look at today. So it's just a lot of different ones, but it's levels in how this information is broken down and received, but it's a lot to it and there's a lot coming into it. But yeah, no stress, guys. Always feel free to watch this video. List of top layer 2 crypto projects by market cap. L2 projects have been gaining traction and uses of Ethereum high gas fees, slow processing speeds. This section looks at the top 4 L2s by market cap. So you have Polygon. Polygon is an L2 scaling solution that allows developers to create scalable and user-friendly dApps with minimal transactions and costs and security. It's just under 85, so we're not really sure as far as the exact price at the current time, but we're going to read this article. Polygon is used by major brands like Sushi Shop, Chain Games, QuickSwap, Mantle, Module EVM layer 2 blockchain that uses optimistic rollouts where transactions are executed on Mantle and a bundle up before being submitted to the Ethereum mainnet. It also leverages EADA, Engine DA for data availability on the Ethereum mainnet. So that's just one in particular. We can go over to Arbitron. Arbitron has a highest value TVL locked. Arbitron is an optimistic rollup scaling solution combining multiple transactions into one smart contract message for bulk processing on Ethereum. As the time of this writing, Arbitron has over 400 protocols with a TVL of 2.20 billion. Arbitron launched its native token RAB, so you just see different projects and stuff like that and tokens on Arbitron. And then you just also have Optimism. Optimism is an optimistic roll-up scaling solution, hence its name, and provides users with cheaper transactions, smoother user experience, and is also one of the top 5 Ethereum layer 2 solutions by TVL with over 872 million. So just when the time was you're reading this, Optimism has released his OP stack where protocols create a specific app layer of layer 2 blockchains based on these. Optimism envisions the Optimism superchain, which is unified of networks of chains built on the OP stack. So you can just see chains developing under chains. So there's so many different scaling solutions on how they want to transact processes through the network. What's the methodologies? What's the theories? How people envision how to handle mass adoption. So you can see it can get really deep and really in depth, but just don't want to superly overwhelm you in this particular video. But we're going to read the rest of this article, then I'm going to get onto some examples to really just show and just highlight, and then we're going to wrap the end of this video. And upcoming layer 2 protocols beyond L2 platforms outlined above. Here's some interesting layer 2 projects. Zksync is a layer 2 blockchain built on Ethereum that leverages zero knowledge rollups to deliver faster, cheaper transactions while maintaining a higher level of security. As mentioned, the zero knowledge ensures the transaction privacy by masking the details of a transaction without dampening validity. Since its launch, the layer 2 TVL has been steadily climbing, reaching a high of 196.555 million. Although it might be partly due to anticipation around the potential Zksync airdrop, so just different things like that. Projects built on the ZK ecosystem largely consist of decentralized exchanges like SimpleSwap. So you can just even click and see the Zksync ecosystem. It just shows total value locked within DeFi Llama, shows how much liquidity is coming in, things that's been built, space, all these different projects are being built on ZK2. So that's even solutions being built on top of other solutions. So you see how this technology can go so many levels down. Linea is developer ready Ethereum equivalent Zksync network developed by Consensus, the company behind MetaMask, compatible with Ethereum, enabling smooth developments of existing applications on Linea. The Linea ecosystem supports a wide range of DeFi projects like Optimisim, finance, NFT projects like NFTs to Me, and utility applications like Hopper, where users can on Linea can track transactions with Hopper's terminal. You got Shibarium, and then you even have layer 3 protocols. So guys, it can definitely get like super crazy. I'm not gonna sound like and pretend like I'm gonna break every single part and aspect of this down, but it is a beginner video and just really exploring just all the capabilities when it comes. So you can see that this technology can get very advanced even from a beginner level with all these different scaling solutions. But let's go on to the next part of our video. Alright guys, so on to the next part of this video. This one is just going over, we're going to make this a general overview to just go over just different points in terms of these type of scaling solutions and just what that actually looks like and just breaking it down and making sense. So let's get into state channels, and the first one we're going to cover is the Lightning Network. So we have scalable instant Bitcoin blockchain transactions for the future, lightning fast blockchain payments without worrying about the blockchain confirmation time, securities enforced by blockchain contracts, smart contracts without creating a on blockchain transaction for individual payments, payment speed measured in milliseconds to seconds. You have scalability, low cost, cross-chain atomic swaps can occur off-chain instantly, heterogeneous blockchain consensus rules. So long as the chain can support the same cryptographic hash function, it is possible to make transactions across blockchains without third-party custodians. So you just see that blockchain powered by smart contracts, the Lightning Network is dependent upon the underlying technology of the blockchain. By using real Bitcoin transactions and using its native smart contract scripted language, it's possible to create a secure network of participants which are enabled to transact at high volume and speed. So you can just actually see, so just breaking down the Lightning Network, the Lightning Network is just basically the main use to have access to microtransactions, and basically how the smart contract is encoded in to match those different transactions on the network to where you could be able to get access to this particular technology or access to a particular asset at a low cost without being able to sacrifice huge amounts of transaction fees, low congestion rates, gas fees, and being able to pay to have a better user experience at a more affordable rate if you wasn't one of the first beneficiaries to be able to interact with that said technology at said rate. But you just hear about Lightning Network. Another scaling solution you hear more so about is Fractal Bitcoin. Different people looking over there, matching that encoded script on that particular asset, and just all this Lightning Network has to offer. But let's look into a little bit of how it works. The Lightning Network is dependent upon the underlying technology of the blockchain. So it just says two participants can create an entry on a blockchain that requires both participants to sign off without spending any funds. Both parties can create transactions which refund the ledger entry to their visual allocation, but do not broadcast to the blockchain. They can update their individual allocations for the ledger entry by creating many transactions, spending from the current entry output. Only the most viewed in version is valid, which is enforced by blockchain plausible smart contract scripting. This entry can be closed at any time by either party without trust or custodianship by broadcasting recent versions to the blockchain. So Lightning Network, by creating a network of these two ledger party entries, it is possible to find across the network to similar routing packets on the internet. These nodes are along the path for not trusted, as the payment enforces a script which is usually the autonomy. Either the entire payment succeeds or fails in time lock. So there's a lot to this, guys. Just reading and just breaking this down, but it's a lot powered by smart contracts. But all to just know is it matches the actual code of that particular or mechanism of that particular aspect. I believe in Bitcoin is like the SHA-256 256. I might be butchering that, but how it's coded in that specific mechanism to match that on a small markable level. But let's get into side chains. So one is like Polygon, so it shows all the different solutions, enabling an infinitely scalable web sovereign blockchain that feels like a single chain, powered by ZK Tech. So you get access to documents, participate in securing the network by matic tokens. You use bridges and swaps on your particular assets. So it shows just a lot of things. Unlock Ethereum scalability while maintaining security with the first ZK rollup that offers EVM equivalents with fast transactions at zero cost gas today. So it just shows the different parts of the world. We are leveraging our core blockchain solutions service to be proactive in the fight against climate. Polygon is a carbon neutral with plans to be climate positive. So it just shows all the different interactions with the ecosystem, how you connect on the different hackathons at Polygon. So it's a lot to look into with Polygon, but it's built on the Ethereum network as a side chain, as an off branch, or just another option to get access to where you may want to interact, but you don't want to interact directly with Ethereum because of how it's built, and the mechanisms on this chain will allow you to do things through Polygon and be able to factor in and flow tons of liquidity. So if you're looking at side chains, that's also another one in terms of like different solutions. And it shows like the portal, it shows all the different ones, developers, community, why use Polygon. So it's a lot to get into. I don't want to get super deep, but this is just to show you a general overview of what's going on in these particular ecosystems. So let's go over to Optimism. This is the optimistic roll up. Optimism Collective, build a world that benefits all, owned by none. So you can hit start building. Let's look at the bridge, benefit together. The super chain is a vision of composable unified network of blockchains that support inherent level activity, powered by the Mint licensed open source network. Develop your own L2, deploy an app, and continue the OB stack. So it shows just all the different ones. The super chain ecosystem is growing. So you have Base, you have Fractal, you have Mode, OP name at Zora. So you just see all these different transactions are coming into the network and you're already validated. But if there's some fraudulent activity on this particular network, you could also have a period where you could be able to transact and challenge that specific transaction and be able to have a reback in terms of how that different system is computed through that smart contract. But it's a lot going on in Optimism. Like I said, you have Base, which I'm already heavily interacted with. I know a lot of people that interact on Zora. So Rainbow Forecaster is one in the social aspect, and you can see MetaMask. So it's connected to a lot of heavy hitters in this apparent run. And then your good project powered by public funds or good funding, society progression hand in hand with economic prosperity. So it's a lot that you can actually go do. Read the vision. So let's read a little bit of this vision, and we're going to go into our next one. Let's build a equitable internet. The traditional web has inherited exploitative economic rule sets that limit power and influence in the hands of few. The Optimism Collective aims to create a new inherent internet that benefits all and is owned by none. The internet is sustained by rewarding public goods through retrofunding. The Optimism Collective is a new model, democratic governance, and is a band of communities, companies, and citizens. Principle that positive impact that the collect should be rewarded with the profit to the individual. Put forth, we're forking capitalism. So it just shows a secure blockchain to where you could build on this particular asset, join different collectives. A lot of people just come on here just being able to build, get access. So this is one that you could look into in terms of like the build, the developer doc, and it just shows all the different aspects, the app from the node, from the wallet. You have the super chain, you have the developer tools. You can just show all these different things, identity testing, wallets, nodes, chain operators. So this is just mainly just give you a general overview once again and show you an example of what an optimistic rollup looks like. On to our next one, Zksync. So you have Zksync, zero knowledge rolled up. So we can just see Zksync is an ever expanding verifiable blockchain secured by math. So you can start building a network of ZK chains. A ZK chain are high performance verifiable modular rollups. Validators powered by Zksync, united in an elastic network. ZK chains can be added or expanded to handle increased transaction volume without affecting the cost of hardware and the requirements. So it just takes a whole mashup of transactions or just funneled through a cartography, different verification processes that processes multiply and high speeds, but also it has zero knowledge of these particular transactions. So it's not like it's taking each individual transaction one by one and looking on it, but it's taking a compiled, transaction and be able to enforce more through that particular network. But let's read in more. Zksync offers a secure one-tap onboarding via Face ID passkeys, eliminating the need for seed phrase and reducing the risk of hacks by automatically creating modular smart contracts at the protocol level. ZK enables a delightful customizable UX, allowing users to seamlessly access ZK in what feels like a single account directly from their application. So you're ready to build on Zksync, and it just shows all the people through the ever-growing ecosystem. You can click on the Discord, you can check on the Twitter, see exactly like what that looks like. So a lot of people, the Elastic chain is an ever expanding verifiable blockchain secured by the map, bringing digital sovereignty to billions. So it just shows all the different possibilities with Zksync. There's so many different apps just being built. So it's so much stuff when it comes to these layer 2 solutions and how all these different things are tied together. Even myself, I'm even learning, just a lot of further L3s and like different solutions on different networks, and what does that look like, and making sense of it all. But just showing Zksync, you'll be able to explore the particular ecosystem. So they have SimpleSwap, Koi Finance, ZK, they have ZK Market. So just showing a different scalable solution and people can get access to zero knowledge roll-ups, and that actually looks like what actually is being built on these particular platforms and models and scaling solutions. So that's very interesting. So that's another one to look at. And then you have OMG Network. So OMG Network has to do with like Plasma, taking, all these different transactions and being able to offset it to just different parties within a different system. But let's read this. The OMG Network is a decentralized public network that allows high throughput, low cost peer-to-peer transactions. With the OMG Network, anyone can transact value across geographies, asset classes, and applications. The OMG Network leverages Level 2 Plasma architecture to provide highly throughput and strong safety guarantee for third parties who wish to build and scale decentralized payment apps on the Ethereum network. And the OMG network allows you to manage assets and transact digital assets that are securely kept on the blockchain. So it shows like the getting started, the table of contents, shows like the API. So there's many different scalar solutions, many different ones that you could look at, and just breaking all this down. But definitely make sure you like, subscribe, comment, share the video, and also just stay tuned because I'm gonna also have my entire summary breaking all this down.
What's good? So I know we're coming up at the end of today's video, so just wanted to give a quick recap and just breaking down what was talked about. But I know we just got into L2 solutions, building on top of this existing tech with the base mainnet layer in terms of Ethereum and Bitcoin and a lot of these other blockchains. You can even mention Cardano. But what exactly does that look like? All right, how do these L2s and all these different options, how did you get these transactions to get more scalable, be more faster in transaction processing time, speed? Because that's what's going to be able to determine whether these networks are capable of influx and mass adoption and mass influxes of new users. Optimistic rollups, ZK rollups, state channels, Plasma, side chaining. So there's just many different L2 solutions, and even beyond the scope, but this is just to give you a general overview. And then also there's the ones that I didn't even name. We have Polkadot, Parachains, Cosmos with the IBC, and you even got Hydra as far as a side chain with Cardano, amongst many others. But what's actually going to motivate you to be able to get into L2 solutions, motivate you to look in terms of these L2s? Well, the first thing I'll just say is scalability. You'll have better scalability and user-friendly interface. These L2s are designed to make the user interface more convenient as a user coming onto the base mainnet and into interacting with the L2. So it allows for better user interface and then also security, how these different contracts are coded in to make it more efficient, faster, better, and a safer use process for newer users coming in. And then also just being able to identify different price entry points. It might be a new opportunity or the said tech. If you get out a certain dollar amount, then you can be able to ride that up depending on the multiplier amount. So there's many different prospects. There's many different aspects when it comes into L2 solutions. But make sure you like, subscribe, comment. Make sure you share the video. Stay tuned for all the videos I'm going to drop and more in the beginner series on the way. Stay tuned.